Hey GPT, I just want to practice some of the questions of the deep learning. So you can ask me the questions of the deep learning which you want to ask me because I just want to practice some English with you.
Absolutely. I'd love to help you with that. Let's keep it conversational. So let me start with a foundational question. What is the difference between a feed forward neural network and a recurrent neural network, and when would you use each one?
Oh, feed forward neural network and recurrent neural network. So, feed forward network means it's a kind of a ANN where like we pass the input to the hidden layer, then we have to pass the input to the output layer. So we are just passing our input to the hidden layer, like just passing. Okay, and in the recurrent neural network, basically we did not pass the data like to the output layer. We first store the feedback of the input, then again we take the another input, and then we again take the feedback of the input, then we compare the to many we compare the many feedback together, that how they are actually connected to each other. So we can say that's an RNN. And the previous concept that I explained, that you have all that's basically a simple ANN. And ANN is like for the images, and it is like for the prediction, like if you want to predict something like car prediction or something. And if you like want to predict price and all, then you can go with the ANN. And if you want to work on a sequential data, if you have like emojis prediction, like a movie revenue movie like good or bad, something like sentimental analysis, I think. So for that we have to go with the recurrent neural network. I hope you got it.
Yeah, that was a great explanation. You really hit the key points. I like how you gave examples for each, like image prediction for feed forward and sentiment analysis for RNNs. If you want, I can keep the questions going. Would you like to discuss something like vanishing gradients or maybe types of activation functions?
Vanishing gradient problem that we always see when we are in the back propagation, when we just calculating the gradients, so it become very small. So our neural network, our model stop learning like complex pattern. It is stop learning complex pattern, when we are trying to find a gradient, and when we are like calculating the derivative of each point. And then again, first we just, let's say we have example, and we are just finding the gradient of one point, and that's great. You find a gradient of one point, you find a gradient of one point, that's a great. Using chain rule of derivative, you have find, okay, that's great, you have find a gradient of one point, that's great. And that gradient value is like, when you find it, you are going to get a very small value. And when you are finding the another value, and then that value is also small. When, and then again you are finding the third value of the like when you are going to find the third derivative, then that value is also like going to be very less. So where, when you are multiplying them, each layer, when you are like multiplying by many layers, when you are multiplying to each other, then you are going to get very less value, like it needs to be zero. So less than one, or like less than uh 0.5. So it might be zero. So whenever a gradient is like becomes zero, so it means our like model, or it our model is going to be stop learning. So we have to don't see the these kinds of problem, like vanishing gradient problem. So yeah, it always happen when we are like multiplying very less value with the very less value, then of course we are going to it, of course we are going to get very less value.
Yeah, exactly. You explained that super clearly. The chain rule and backprop just keeps shrinking those gradients as they go backward, especially in deep networks. And yeah, that's why you end up with the model not really learning those deeper patterns. And that's where things like using ReLU activation functions or things like batch normalization or even
Yeah, like we
LSTMs.
use a ReLU activation function, where if the value is like less than the zero, then of course we are going to provide it. We are just going it with the zero. And if we something like any value is like more than the zero, then we are going to provide as the same. But if any value is zero, then, or any zero, or like let's say less than zero, then we are going to provide it zero. And So yeah, this is the thing that always we see, and yeah,
Exactly. Yeah. Yeah. Exactly. Yeah. Exactly. Relu is super. Yeah. Exactly. Relu is super useful. Yeah. Absolutely. It helps avoid. Right. It helps avoid those small. Exactly. And it's also really simple to compute, so it speeds up training a lot, which is why it's such a go-to activation function these days.
yeah, like these things always happen. So when we are like finding the derivative and then multiplying them across by many layers, so we see the gradient descent problem. So now you can ask me the another question which you want to ask me.
Of course. Let's switch it up a bit. Can you explain what a convolutional layer is in a CNN and why it's useful for things like image recognition?
Oh, of course, I can tell like what is a convolutional neural network. So it's a, deep learning model that is like it is a sequential model that we always use for the images, and it basically it provides us a small filter which moves over the image to extract the important features, to extract the edges of the image. Like maybe it is so we use like multiple filters we use. Maybe some filter is extracting the shape of the nose, maybe some of the filters is extracting the ear shape, ear shape, ear edge. Maybe another filter is extracting the at how your ear, how your nose, your eyebrows, how your hair and your body, how your hand is bent, or like what is the edge of your hand and everything. So basically every filter is like doing its own work here. So this is how actually a CNN works, and it is like that's why it is like good for image recognition, because we have lots of filter and we use it. Then we also, after that, we provide the ReLU, and then we applied pooling layer for the like important feature we have to extract.
That was a fantastic explanation. You really broke it down, how each filter acts like a little feature detector and how pooling then helps summarize those features. Yeah, that's exactly why CNNs are so powerful for image tasks. Great job.
You can ask me another question.
Absolutely. Let's go a bit deeper. Can you tell me what overfitting is in a neural network and what techniques we typically use to prevent it?
Oh, overfitting. I have like seen overfitting also in the ML and also in the DL. So overfitting means when our model is like performing well on the training data, but it is like failing to perform better on the testing data. So we can say on the unseen data and inseen data. So it's like overfitting. So for that, I think we have to use dropout, right? Where some of the neurons get turned off.
Yeah, exactly. Dropout is one really common technique. And we also have things like early stopping where we monitor validation loss or L2 regularization, also called weight decay, to keep the weight small. So yeah, exactly. That's how we control overfitting.
Okay, thank you for asking and discussing with me some questions of the deep learning.
You're very welcome. I really enjoyed the conversation. If you ever want to practice more or dive into other topics, just let me know.